Hello and welcome to this R tutorial. In the previous tutorial we imported our mall dataset and we prepared our data correctly by taking the two columns we are interested in, the annual income and the spending score. So we created this variable x that contains these two columns. And now things are going to get much more interesting because in this tutorial we are going to build our dendrogram and we will use it to find the optimal number of clusters, exactly like we did in the k-means section, where, as you remember, in step 2 we used the elbow method chart to find the optimal number of clusters. Well, here in hierarchical clustering step 2, we will also look for this optimal number of clusters, only this time we're not going to use the elbow method, we're going to use the dendrogram. So let's do that right now. The very cool thing about it is that we only need one line of code to build this dendrogram. So let's write it. Let's write this line of code. We start by creating our variable dendrogram, then equals, and then we're going to use the class hclust. So let's type hclust here, and then let's press F1. And here we have all the info of this hclust class. So let's look at the arguments. Here we only need the first two arguments. The first argument is a dissimilarity structure as produced by dist. And in our case, this parameter is going to be the distance matrix of our dataset X, which is a matrix that tells for each pair of customers the Euclidean distance between the two. So that means that for each pair of customers, we take the two coordinates annual income and spending score, and we compute the Euclidean distance between the two based on these coordinates. Okay, so that was just to explain the first parameter of the hclust class. And so let's input it in our code. We input dist, and in parentheses x, comma, and then method equals Euclidean. So that specifies that we want to compute the Euclidean distance matrix for our data x. Okay, so that's the first parameter, this distance matrix. And now the second parameter is the method. So this method is simply the method used to find the clusters. And like in Python, we're going to choose the most common method, which is the ward method. Here it's called ward.d. And it's actually a method that is trying to minimize the variance within each cluster, kind of like what we did in k-means when we were trying to minimize the within cluster sum of squares. Well, here it's based on the same idea, but instead of trying to minimize the within cluster sum of squares, we're trying to minimize the within cluster variance to find our clusters. So here we write method equals ward.d. So that is the end of the line to build this dendrogram, and now we just need to plot it. So just below we're going to write plot, then in parentheses dendrogram. Then let's give it a title by typing main equals paste parentheses dendrogram in quotes. Then let's give a name to the x-axis by adding xlab equals customers, because in the dendrogram all our customers are going to be on the x-axis. And then finally let's give a name to our y-label. We're going to call it Euclidean distances, and that's because in the dendrogram the vertical lines that we're going to see are actually the Euclidean distances of the clusters, that is between the centroids of the clusters. Okay, so we're good to go with our plot, and our dendrogram actually. So let's select all this code section here, execute, and here is our dendrogram. So let's have a look at it. I'm clicking on zoom here to make it bigger. Okay. And now let's try to find the optimal number of clusters thanks to this dendrogram. So as Kirill explained in the intuition section, to find this optimal number of clusters, we need to find the largest vertical distance that we can make without crossing any other horizontal line. And then we just need to count the number of vertical lines at this level. Okay, so let's start by finding the largest vertical distance. So it's not here, obviously. Then maybe this one, it's quite a large distance. That would actually give us 3 clusters, because as you can see here, I'm crossing 3 vertical lines. Definitely not this one. And here we have another large distance. You see, from this point to this point is quite a large distance. And then below, obviously, we don't have any large distance. So now the question is, what is the largest distance between this distance and this distance? Well, if you have a better look at it, we can see that the largest distance is actually this distance. And how many vertical lines do we have at this level? Let's see, 1, 2, 3, 4, and 5. So that means that our optimal number of clusters is 5 clusters. And that's of course a relief because that's what we obtained with the k-means algorithm using the elbow method. So everything is fine, everything is perfectly coherent. So we well completed our second step, and now we're ready to move on to the next step, which is to fit our hierarchical clustering algorithm to our data X. And that's what we will be doing in the next